Hi, you rates. I was just going to review your circles investigation that we were looking at last week. Now, I managed to find a piece of string and just like a sort of a ruler or like a just any measuring device, and I could do this fairly accurately. So, if you were using such like an iPhone, um, charging cord or something like that, it's not ideal because you're trying to form a perfect circle. So what I'm trying to do is with an iPhone cord, a lot of the time I'd sort of bend it around, and when I get down to here, it sort of goes across here and does all sorts of things. So anyway, I've got my piece of string, and I have used that piece of string to form as best I can a perfect circle. And of course, so I wrapped it around here. And when I did it for this first circle, I got a circumference of approximately, it was pretty good, pretty close. I got about 13.5 centimeters. Okay, so wrapping that around as best I could, 13.5 centimeters. And the diameter, which went as close through the center of the circle as possible, the diameter, we had 4.1 centimeters. Okay, and of course the radius, well, the radius is half of that, 41 centimeters. We could say that that's 2.05 centimeters. And when I do that in a calculator, 13.5, if I do 13.5 divided by 4.1, I'm pretty happy with 3.29. So it's so probably it's pretty close, 3.29, pretty close to pi. When I did the second one, I got a circumference. When I measured us around, I got about 15.5 centimeters. It was pretty close. I tried to do my best. I sort of would sort of just mark out on the piece of string roughly when I wrapped it around and it got to there. Wasn't perfect, but 15.5 centimeters. And then I measured the diameter across, of course, and I was trying to do it as close as I could to the center, through the center of the circle. And that gave me, I got 4.9 centimeters. And when I divided them, that's going to be 2.5 or just half of the diameter. And the circumference divided by the diameter, what did I get? Let's 15.5 divided by 4.9. Yeah, that was pretty close. 3.16. Yeah, that's pretty good. Okay, so I got 3.16. Now, obviously, we're going to have our results are going to vary. With the third one, the smallest one, that was obviously can be a bit hard to do, but I wrapped that around and I got around about 7.5 centimeters. 7.5 centimeters, and I measured. Look, the diameter you should get pretty close to the actual, because we're just doing a straight line, aren't we? We're just measuring from there to there with a ruler. And that's going to be, what do we have? 2.4 centimeters. And when I measure it around, we had 7.5 divided by 2.4, 3.125, also pretty close, 3.125. And of course, half of that was 1.2 centimeters. So hopefully you're seeing there that when we looked at our value for pi, we looked at pi as sort of this 3.14159 if you do it in the calculator, and so on and so forth. We're getting pretty close to that, and we're obviously just doing a small experiment, which has some limitations for sure. Okay, and finally, the other circle, I got 10.8 centimeters was my circumference. So I wrapped that around and I measured it, and I was pretty close, I reckon. Obviously, you're going to get things that like this, and that's clearly you're going to measure, and if it's going to be longer than the actual circumference, so it's not going to be perfect. But 10.8 centimeters, and I've got a diameter of 3.1 centimeters. And when I do that, well, that's going to give me 1.55, or half of that is the radius, and we're looking at 10.8 divided by 3.1. 10.8 divided by 3.1. 3.48. So that one wasn't as close. All right, so first of all, the one that we got the closest, the one I got the closest was the larger one. There's more margin for error. In other words, you can have an error. If you have a small error, it's not going to be affected. And as you can see, that's pretty close. Likewise also, I got it pretty close for the C, the smaller circle as well. These ones, clearly I probably didn't measure as accurately, but hopefully you can see that we're getting pretty close. In fact, it is true that if you have a perfect circle, the circumference of the perfect circle divided by the diameter is going to be pi. So we notice that over here, what should you notice? We should notice that the values are between, well, I've got between 3.12 and 3.48, and of course these are going to be close to our value for pi. What is the relationship between D and R? Well, hopefully we can see that the radius, the diameter is 2 times the radius. What might be the rule for the circumference of a circle involving D? So if we get the circumference of a circle and I get multiply that diameter by pi times D is the circumference. Okay, so in other words, if I divide the circumference by the diameter and get 3.14, well, if I multiply the diameter by 3.14159 pi, then I'm going to get the circumference. And likewise, we can also say that 2 times the radius is also the diameter. So that's going to be, 2 pi r is another way of doing it. So hopefully you can see that if you were to get a perfect circle now and a piece of string, maybe you can look for a much bigger perfect circle and see how close you get. And you'll be surprised how close you will get to pi. Clearly, the more accurate you are, the better. If you're using a thin piece of string, which can be sort of made to form a perfect circle, then you'll find that you're going to get very close. All right, girls. Now, just quickly, I wanted to go through a little bit of theory with you. So if you're watching this, I have emailed you and attached to Teams the notes for 4C, areas of basic shapes. A lot of these you have seen in Year 7 and will be a bit of a recap, and some you may have not. Okay, so first of all, if we're looking for finding area, we've got to look at, first of all, we've got some conversions. Now, we've got here marked out a centimetre, and a centimetre, of course, has 10 millimetres to a centimetre. So what we could say then is 1 centimetre squared is, well, we've got 10 millimetres times 10 millimetres. And 10 times 10 is 100, so 100. And millimetres times millimetres, we're looking at square millimetres. So what I'm trying to say is, can you see there that this area here that I'm shading right now, that's 1 millimetre squared. And there is exactly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 10 of those is 100. So there's 100 millimetres squared in 1 centimetre squared. And so when we're doing these, now it can be nice to have a table of these, and we'll use these to convert, but basically what we're saying is that if I'm going from millimetres squared to, or centimetres squared to millimetres squared, then we multiply by 10 squared, or 100. We multiply by 100. Now 10 squared is 10 times 10, which of course is 100. So we're going to have to use these conversion tables, but of course we can also draw a square. Now let me go through an example. It says convert these area measurements to these units shown. So I've got centimetres squared to metres squared. Well, let's draw a square. Now 1 metre squared is a metre by metre. So if I've got 1 metre squared, that is 1 metre by 1 metre. But what is 1 metre in centimetres? Well, 100 centimetres is a metre, and 100 centimetres is a metre. So we can say that and this is now using any tables, 1 metre squared is 100 centimetres by 100 centimetres, which is 100 times 100 is 10,000. We have 10,000 centimetres squared is 1 metre squared. So it's not the same as just using your unit conversions. Like 100 centimetres, because 100 centimetres is 1 metre, doesn't mean that 100 centimetres squared is 1 metre squared. No, because we're looking at 2 dimensions. Okay, so we've got to, if we break it up into a square, we can, so in other words, if I want to go from metres squared to centimetres squared, then what I have to do is we need to multiply by, it says it multiplied by 100 squared, or, well, 100 squared we have sort of recognised is 10,000 by doing this little conversion. So 10,000 is how many decimal places? How many zeros? 1, 2, 3, 4, which means that if I'm doing this conversion, I'll get my other pen here. If I'm doing this conversion, then hopefully you can see that 0.248, I'm multiplying by 10,000. So I'm going 1, 2, 3, 4 decimal places, and that's going to be 2,480 centimetres squared is our answer when we're doing these conversions. Okay, likewise over here, I'm going from millimetres squared to centimetres squared. So let's draw what we've got. We've got a centimetre. So let's go the larger one. 1 centimetre squared is 10 millimetres. 10 millimetres by 10 millimetres. Now, you could look at your conversion table, and if I do millimetres squared to centimetres squared, if I'm going across there, it says that I'm multiplying by 100 squared again. Okay, so so that's metres squared, sorry. If I'm going from millimetres squared to centimetres squared, then it says here I'm dividing by 10 squared, which is dividing by 10 squared is 10 times 10. So I'm dividing it by 100. Well, let's see why that's the case, because we can hopefully see that 1 centimetre squared, a squared centimetre is 10 millimetres times 10 millimetres. 10 tens are 100 millimetres squared. So if I'm going from millimetres squared to centimetres squared, we're going to divide by 100, which of course is this dividing by 10 squared, which is 100. Okay, so again, you can use the table, but just remember that a lot of the time it's saying divide by 10 squared, divide by 100 squared, which of course is 100, 10,000 and so on. Sometimes these can be quite big. All right, so we've got 3,100 divided by 100, which means I'm going back 2 decimal places. 31 centimetres squared is 3,100 millimetres squared. So we're going back 2 decimal places, and that's our answer. Okay, with those in mind, I'm going to pause this. I'm going to get you to try these ones here. Again, likewise, it's very similar. You've just got to be able to recognise. Go back to your conversion table if you like, or you can draw a square. So I'm going to reveal my results in a second. Okay, so hopefully you have had a go at this. 3.51 metres squared. Let's first of all, I'm not going to use a conversion table. I'm just going to draw a square. And I'm just going to draw a square metre, and a square metre, we're looking at centimetres squared, is 100 centimetres. 100 centimetres by 100 centimetres. Okay, so if I then do 1 metre squared and do the length and width of a square, well, they're both the same, aren't they? It's 100 centimetres times 100 centimetres. 100 times 100 is 10,000 centimetres squared, which means that if I'm going from 3.51 metres squared, I need to go multiply by 1, 2, 3, 4. We're going to multiply by 4, which means our decimal point's going to go there. Okay, 10,000 is 4 zeros. So we've got 35,100 centimetres squared after our calculation. Likewise, again, I'm not using any table here, but of course, if I've got, let's say if I've got 1 centimetre squared, that is 10 millimetres, 10 millimetres and 10 millimetres. So we can say that 1 centimetre squared is 10 millimetres by 10 millimetres, which is going to be 100 millimetres squared, which means that if I'm going from millimetres squared to centimetres squared, I need to divide by 100. Clearly, a centimetre squared is much larger than millimetres squared, so we're going to have less of them. So we're going to have to divide by 100. So 150 divide by 100, 2 decimal places now there, so we've got 1.5 centimetres squared. You have to try a few of these to get the hang of it. Yes, you can use your table, but we're doing this without a table. Okay, so now what we're going to be looking at is just finding, so the area of a rectangle is, of course, it says base times height, but of course we're going to call this a length and width. Okay, and area of a triangle is a half times. Now the triangle, if I have a rectangle, a triangle is exactly half a rectangle. So that's where this half comes from. And if instead of calling this length and width, we call this base and height. So, let's do this as the base. And that's going to be a half times base times height is our formula for a triangle. But really, it just comes from the fact that we've got half of a rectangle. Okay, so they're sort of related. And a parallelogram is just a sort of a rectangle skewed. So we're looking at A times B. Okay, so let's go ahead and do these. I'm going to go through these ones and get you to do some ones in a second. All right, so find the area of these basic shapes. So the area is equal to the length times the width, which of course is 6 times 2. And of course, it's going to be 12 centimetres squared. Remember, with area, we're looking at centimetres, metres, millimetres squared. So we're looking at square units there. Likewise, over here, we've got, this is a parallelogram, which has been offset. And again, it's very similar to the rectangle formula. It's been skewed. And we can say that the area is equal to 8 times 3, which is 24 metres squared this time. And for our triangle, the area is equal to a half times the base, which is 13, times the height or the perpendicular height, which is 7. 13 sevens are 91. Divided by 2 is 45.5 metres squared. Okay, now you're also going to have these composite shapes here. Now, I'd like you to try this one first. Just remember though, if I get a rectangle, think about this one. If I get a rectangle, I'm going to give you a little bit of a hint. If I get a rectangle and then I subtract a triangle from it, I'm going to get this, what's left over here. So we're going to have these composite shapes like this. So let's set them out like so, and I'd like you to have a go before I reveal it and go through my answer. All right, so how do we tackle this? Well, we could do it a number of ways. What we could do is we could say, hey, I want to do the area of a rectangle, and then I want to subtract the area of the triangle, and that will give us this area here. So I'm going to do it like that. So the area of the rectangle is going to be the length times the width. We're looking at 10 times 6 for that. And then a triangle. Well, a triangle is a half times the base. Now the base there is 10 centimetres, or sorry, 10 metres. And the height, the perpendicular height, we're looking at this distance here is times 4. Now we're looking at 10 times 6 is 60. And then we're taking away 10 times 4 is 40. A half of 40 is 20. You can use the calculators for this though. So we're taking away 20, which is going to be 40. And what are we looking at? We're looking at meters squared. Now over here, likewise, we've got a couple of rectangles, and we can sort of split that up into two if you like. We've got over here that this is 1, so we've got sort of, if you like, we can say that it's like area 1. The area is equal to area 1 plus area 2, which is, well, we've got 3 times 3, so we've got a square there, 3 times 3. I'm using brackets just to split them up. And then we've got 1 times 1.2. 3 3s are 9. 1 times 1.2 is 1.2. Add them together is going to be 10.2 millimeters squared. Okay, so you can see there that we've got composite shapes where we add. Clearly it made sense to add 1 and 2 together. But over here we actually sort of worked out the entire rectangle, one area, and then we sort of subtracted this area away to get this area in here. Okay, so you'll need to do the same. Now, likewise, can I get you to this time? Pause this now, try this, and I'm going to go through and reveal my answer shortly. All right, so in the first one, we used the fact that we could subtract this triangle's area from a rectangle, and then that's going to leave it with what's in there. So you can see that I've done the rectangle, subtract the triangle, the rectangle length times width, in brackets, a triangle a half times the base is 10, so of course I'm talking about this distance here, times the perpendicular height, which was 3, in other words, we're looking for this distance here, which is 3. And if you like, think about it as half a rectangle. That's where it comes from, half a rectangle. Okay, so that triangle there is half of this rectangle of base and height, if you like. Okay, that was 80 divided, take away 15, which is 65. Over here, that would make sense to add some areas. So I'm going to have area 1 plus area 2. And when I add those together, we've got 3 times 3, that's a square. 3 times 3, which is 9, plus we've got this area here. Now, that's going to be, that distance there, across there, is going to be 3, plus another 3, plus another 3. So that's going to be 9. And then we know that this distance here is 3. So that's 9 times 3. Which is going to be, we've got 9 plus 9 3s are 27, so that's going to be 36. And of course, we're looking at millimeters squared for area. Okay, so hopefully, you can now work your way through and try those questions on 4C, and we're going to have a well, we'll have a work lesson next lesson, but if you can get started on those 4C questions, that'd be great. Thank you, and we'll see you in class tomorrow.